picking up where we left off in P1. I asked you guys to work on B, right? Looks like we got some progress made. So if we're graphing this, the real number is greater than or equal to 0. That means minimum, I have to have 0 on my number line, right? A few other numbers are always nice. Not necessarily required, but you know, well, kind of required for me, I guess. What'd you do? How'd you graph this?
Brackets over 0.
Oh, a bracket at 0, and which way am I shading?
To the right.
And I kind of gave it away because I made my bracket open to the right, didn't I? Your bracket is opening whichever way you're shading. And Noah, why'd you say bracket?
Because it's greater than or equal to.
Ah, because it's greater than or equal to, yes?
Yep.
So we're using a bracket. And if you didn't already, I guess this would have been an easy one. I could have written the inequality first. Real numbers greater than or equal to 0. To write an inequality, we're using what? X. Greater than or equal to sign. And 0. Right? That's what the problem asked us to do. If you recall from yesterday, I was having you, I was practicing interval notation with us. Hopefully we're starting to get a little feel for it. So I always like to, when we're first learning this, I teach from the graph. What's graphed? Where does my shading begin? My shading begins at where? 0 with a bracket, comma. Where does my shaded interval end?
Infinity.
That right arrow, which is represented as positive infinity, and I always use a parenthesis with infinities. Okay? Positive infinity will always come last in a situation, and if we get one, yeah, negative infinity would always come first because that would be on the left. With interval notation, we read left to right. Okay. So, on the last section here for this part, convert the following from interval notation to inequality notation or vice versa. Now, maybe that means you need to sketch a graph. Or maybe it means this is a piece of cake for you and you don't need to sketch a graph. You do you, okay? So this first one, it's in interval notation. Bracket, -6, comma, 3, parenthesis. I'm going to sketch a little graph. And again, it's not that we have to, but if I just sketch a little graph here, and I put -6 and 3 on the graph, what's the shading look like if you had to do the graph? We would start shading where?
From 6 to the right.
We'd go 6, and we're going to shade over to 3. -6 has a bracket, 3 has a parenthesis. So that's what the graph looks like if you need that visual. Didn't have to do it. So how do I write an inequality for this situation? Where is my shading?
-6 is less than or equal to x, and then x is less than 3.
Okay. Yeah. This is where the numbers are between, right? So this looks like the first part B, or it looks like the part A directly above it. Okay, it's those situations where when your shading is in between two numbers, I'm putting X in between the two numbers, smaller number on the left, larger number on the right. Okay, my shading goes left from 3, so it is less than 3. My shading goes right from -6, so we could say greater than -6. But in this compound inequality, greater than -6 is flipped to read -6 less than x. Of course, there was a bracket, so that means less than or equal to. Okay? Not too bad? Okay, you guys don't appear freaked out. That's good. That means we're getting on to this interval notation. Okay, negative infinity to -1 is the interval notation. And again, what's the visual on the graph say? There's -1. Where's the interval that's shaded? The interval shaded is negative infinity to -1. That's what's shaded, right? There's your visual. What's the inequality for that?
-1 is greater than x.
Okay. He said -1 is greater than x. I would have written it the other way around, just because I always tend to put x first. Not wrong. It's equivalent. I would have put x first and said that this is x is less than -1. I'll accept both. Okay. They're equivalent. I only encourage this just because some people struggle when we put x anywhere other than first. Some of you are fine with x being either place. So, either or. Okay, C. It's an inequality. Can you do this without the graph or no? I got some yeses and I got some not a chance. So, those of you that tried this without the graph, I mean, what is this saying here? X is where?
In the middle.
It's in the middle, right? X is between -2 and 3. So where's my interval going to begin? -2. Where's my interval going to end? 3. Parentheses or brackets?
Brackets.
Equal to marks? Tell me they both have brackets. You didn't have to do the graph there. However, if you did the graph, right? I mean, again, I'm only using the graph there as a teaching tool. If you need it and it's helpful, use it. If it's overkill at this point for you, then don't use it. I don't care. Okay. Does interval notation make a little bit more sense? I mean, yesterday I was told it was gibberish when we were on the other page and I was using A's and B's. So is it less gibberish now?
Yeah.
Okay. When you go to do homework, when it's talking about, actually I think in this homework they give you the directions, don't they?
Yeah.
Put it inequality, put it interval notation. Later on as we go, when we get to solving inequalities and that type of stuff, it will be, I want everything done in interval notation. Okay, so you kind of have to change over your brains from algebra when we want inequalities, well, really all of your teachings up until now, and work to understand interval notation. Okay, bottom of this page. Not really work to do here, but just a little bit of review to talk about. These properties you've been learning since, I don't know, what, kindergarten maybe? I honestly, you've been learning them for a long time, and I only know that because as my kids went through elementary, I was like, wait, you guys have known properties this long? Now, do you remember their names? No, but you know what they do. Commutative property, x plus y equals y plus x. I'm telling you that 2 plus 3 is the same as 3 plus 2. Works for multiplication as well. 2 times 3 is the same as 3 times 2. Okay. Associative property. That's just saying that if you have 3 pieces being added, it doesn't matter which 2 you add first. I could have the parentheses around the y and z and add those first, and then the x. Or I could have parentheses around x and y, and then add z. So associative property, when you're trying to identify it, I always think of it as the pieces are in the same order, the x, y, z. It's just the parentheses move. Works for addition or multiplication. Okay, distributive property. Okay, you haven't been, well, I don't know. You probably have been learning this one from elementary. Definitely wasn't called distributive property. But x times y plus z means what? X can distribute. X can be multiplied by y plus x multiplied by z. Okay. Identity properties. It's identity properties because there's an addition and a multiplication. Identity is what can I do to x? What can I add to x to get it the same? That's your addition identity. And then there's also a multiplication identity. What can I multiply by something and get it to be the same? So what do we add to something and get it to stay the same? 0. So it's the addition identity or identity property of addition if you add 0 to something. What do you multiply something by to get it to stay the same? 1. Okay, and that's your multiplication identity or identity of multiplication. I can't remember exactly what phrasing this book uses, but okay, inverse property. Inverse property says what can I add or multiply by to get the identity over here. So the inverse property says, okay, how can I get the identity of 0? If I have x, what do I add to it to get 0? Yeah, you're going to add the negative version, right? So if I have 5, how do I get 0? I add -5. So 5 and -5. how do I multiply to get 1? Huh? How do I multiply? What do I take to multiply by x to get 1? There's a word out there. I don't know if you guys will know what word I'm looking for. Huh? Inverse is one word, but we also talk about it as being something else. Yeah, reciprocal. Because what is x to the negative 1 really? What's that negative exponent do? It takes it to the denominator. And so that's really 1 over x. And so this is saying that x over 1 times 1 over x will equal that 1 there. Okay, so again, multiplying by the reciprocal will get you your inverse of 1. So just properties to be familiar with. I think there's a section homework where you just have to identify what property is being used. When you identify, don't just tell me commutative or associative or identity. Throw in, is it of addition or multiplication? Okay, so if it's commutative, is it commutative of addition or of multiplication? Let's see, exponential notation. A to the m. A is called our base. M is called our exponent. Old news, right? Do we remember our properties of exponents? Okay, some. And these are things that we have to be comfortable with, right? So u to the m times u to the n. That one's saying if the bases are the same, so we have the same u, and we're multiplying, what's the shortcut? Add the exponents. In similar fashion, if you're dividing, if the bases are the same and you're dividing, the shortcut is to subtract the exponents. Okay, guys, anything raised to 0 is 1. We definitely talked about that. We already talked about negative exponent. When you have a negative exponent, how do you get rid of a negative exponent? Move it to the denominator. And so u to the negative is 1 over u to the n. Power properties. uv to the m. That m, as long as this is multiplication in here, this doesn't work if it's u plus v, but if it's multiplication, that m goes with both the u and the v. So u to the m, v to the m. Okay, here we go. A power raised to a power. There is no common base, is there? There is one base. So when it's a power raised to a power, that is when you are multiplying. And here at division, this is just saying that u divided by v, m goes with the u, and it goes with the v. Okay, it goes on both places. Again, doesn't work with addition or subtraction, but works with multiplying and dividing. Those should sound familiar, right?
Yeah.
Okay, let's go to the next page. And those were the very basics. One other basic, scientific notation of the form C times 10 to the n m. Where, first of all, remember this front number, C, has to be a number between 1 and 10, is generally how I speak. Now, when I say between 1 and 10, think between 1.0 and 9.9999999. In other words, it's always a one-digit number in front of the decimal. And then m is an integer. With scientific notation, that exponent is an integer. Okay, let's go through and look at some of these examples. Okay, let's start easy. Identify the base and exponent of negative 3 raised to the 5th, where negative 3 is in parentheses. What's my base? Negative 3. What's my exponent? 5. Challenging, wasn't it? If only they were all that easy. Okay, B. Negative 3 to the 5th. Same problem, right? Except that there are no parentheses. So, how does that change? Or does it change? What? The base is just 3. My base is not negative there. Okay. What's being raised to the exponents is just the 3. And what is the exponent, of course? 5. So are we aware of the difference here? And this is where I always stress, and it was true on your scientific calculators, and it's going to be true on these graphing calculators. When you raise a negative number to an exponent, If you're truly raising the negative number to an exponent, you have to use parentheses. Okay? These, because they're an odd exponent, would work the same both ways. But if it's an even exponent, it doesn't. So negative 3 to the 5th with parentheses means we're doing what? Negative 3 times negative 3 times negative 3. I need 5 of those guys, right? That's what negative 3 to the 5th means when there are parentheses. You're multiplying that negative 3 however many times. What's it mean when it's the negative of 3 to the 5th? It's a negative out front, but what am I multiplying? Just the 5 3s, right? So if that negative is not in parentheses, it's just indicating this answer, no matter what the exponent is negative. And so multiplying all those pieces. So this one, if this was, say, negative 2 to the 4th. I know a lot of times we think, oh, even exponent's going to be positive. But no, this would be negative of 2 times 2 times 2 times 2. So just be aware of the difference there, right? The calculator knows the difference too, so you have to be careful about whether or not you need parentheses. Okay. Our exponent examples. They're kind of big and bad, aren't they? And I'll tell you, the exponent examples in homework are kind of big and bad. So it's pre-cal. You guys should know what you're doing at this point. Hopefully, maybe. Okay, thoughts? 2ab to the third times 5a to the second, b to the fifth. What's your, I don't want to use the word guess because I think you're more educated than that.
Hypothesis.
Hypothesis, there we go. Get a formal word here. So what's the hypothesis? Okay, exponent properties, put them together. So what are we thinking?
No. Not distribute. That's the wrong property.
I mean, essentially, this is just one big multiplication.
Yeah, we multiply them and then we add the exponents.
Would it be like 10 and then a to the third and b to the fifth?
Check your B.
B to the eighth. I wrote 8. I just said 5.
Okay, well, I was gonna say you were on the right track, so I knew you just overlooked looked at something. So first of all, 2 times 5, those are whole numbers out front, yes? I'm not adding those. 2 times 5 is 10. A, what's on this first A? Invisible 1. So 1 plus 2 is 3. And then B to the 8th. Should be pretty simple, technically, depending on how much our brains are still on summer vacation. Okay, B. Instead of multiplying, we're going to
Subtract or divide.
divide officially, but the shortcut for division is we're going to subtract. So when I subtract, this becomes u to the, check again, u to the third, because it's 2 minus negative 1, v to the, check again,
Negative.
negative 2 minus 3
Oh,
is negative 5.
I had negative 3.
Now, okay, use your knowledge. If we're told to simplify, which is what the word was, is this a final answer? No, because we're not allowed to leave negative exponents. So if I'm not allowed to leave exponents negative, go one more step. Okay, u to the third stays on top. It's already positive. V to the fifth moves to the denominator to make that negative exponent positive. So u to the third, v to the fifth. Okay, not horrible. I think it's coming back. Maybe. Okay, what about C? X to the second over 2, parentheses, raised to the negative third power. kind of combines several things again.
X to the. Okay, no, so it's X to the 5th.
X to
Over.
the negative 6. You could X to the negative 6.
X to the -6.
Yeah, looks like the distributed function.
X to the -6 times or divided by.
That negative kind of throws a kink in things, doesn't it?
Mm,
Okay. And okay, so first of all, you guys were kind of discussing this. X to the second raised to the negative third. Yes, it's going to be a power raised to a power. There's only one X, so you are going to be multiplying those powers. And yes, that -3 has to go down with the 2, doesn't it? Okay, and then you've got to flip them. Now, a trick I tend to do, and you'll see a lot of math teachers do, is I tend to flip this before I place that exponent. And I don't want to use the word distribute. I started to, didn't I? Because it's not exactly distribute, but it's what our brains think. So what I tend to say here is, okay, first of all, I'm going to flip my fraction. 2 over x squared, and now that's raised to the positive third. That's the kind of easier way to get rid of the negative exponent. So because now I can see it better. Now, am I saying, could you have done x to the negative 6th over 2 to the negative third? You can do that because we're going to end up in the same step here in a moment. Because once I take that negative, it causes me to flip the fraction. Now, what's this 3 have to do?
distribute.
It has to go with both pieces. So now I'm going to have 2 to the third over x to the 6th.
8 over X to the 6th.
Final answer I am going to prefer is 8 over x to the 6th. Which we would have gotten here also, right? Because you would have taken your negatives, and okay, negative on top goes to the bottom, negative on bottom goes to the top. So you would have gotten there. This is just kind of a cleaner way to do it, especially had there been multiple pieces in here. I mean, how many negative exponents do you want to write out? So, okay, D uses the word expand. A plus 2 with an x afterwards. Yeah, what are we really doing here? This is a distribute. Does it matter that the x is out back instead of out front? No. That x will still distribute. A times x is ax, plus 2 times x is 2x. What is ax plus 2x?
I don't.
Okay, good answer. Ax plus 2x. I gotta try. To get you guys.
A2x squared.
Okay, E. Factor. Oof, there's another word. Factor, and that is 3y minus by, as in B for boy, boy y. That doesn't sound right either, but
What?
what do we factor? 3y minus by. Yeah, they have a y in common, don't they? So it's a GCF if we can, right? We're going to factor out the GCF of y. When I divide the pieces by y, 3y divided by y becomes 3 minus by divided by y becomes b. So basic factoring there. Okay, scientific notation. 2 and 375 thousandths times 10 to the 8th. We're going either to or from scientific notation. This way, we're going out of scientific notation. How do your brains do this one? Move the decimal.
We're using this calculator. How do I do that?
We're not going to use the calculator for this.
Well, I know you could do it with your hand, but I don't know how to do the.
Okay, well, I don't want to teach calculator on this right now. I want you doing it by hand right now.
Okay.
Because when we get to this one, I want to show you, I want to talk about how we can do this more without the calculator than with it. So, we'll talk about it. Don't get me wrong, Emma, but I don't want to do it right now. Okay, so 2.375 times 10 to the 8th. That 8 says we don't add 8 zeros. We move our decimal 8 places. Which way?
Right.
To the right, because it is a positive, right? So we're actually going to be adding 5 zeros. Okay. Commas go every 3 from the right. So 237,500,000.
A lot of money.
Sure, put a $sign on there, right?
Yeah.
Okay.
That's fine.
What about B? This time we're going into scientific notation.
Negative exponent.
It's a negative exponent because I don't think left and right on this. I think because it was a very small number. It's a decimal number, so that means it's a negative exponent, as opposed to this millions number where it's not a decimal. So that's why I think this one has a positive exponent, this one has a negative exponent. Where are we going to put that decimal? Yeah, between 3 and 4, because we're trying to make that a number between
1 and 10.
1 and 10, or 1 and 9.99999, you know, whatever. So this is going to be 3.49 times 10 to some negative exponent of, do we agree on 7? I haven't counted. Okay, and you're not counting zeros, are you? You're counting decimal to decimal. Okay, C. Do me a favor, don't pick up the calculators yet, okay? Yes, you could just plug this into your calculator and you could do it, okay? However, let's talk scientific notation, okay? What do you know about 370,000?
3.7 times 10 to the 5th.
3.7 times 10 to the 5th?
Yep.
We all good with that? And then what about that 4 and 5 number?
4.5 times 10 to the 9th.
4.5 I can definitely agree with, because that's making the number between 1 and 10. And I'm moving that decimal 9 places. Okay? 18,000.
138 times 4.
Okay? 1.8 makes the number between 1 and 10, 10 to the 4th. Okay. This is not our first rodeo with scientific notation. I feel like we're getting there. Now, here's the deal. Before you grab the calculator, and I'm going to use the calculator for bits and pieces of this to keep it easier, multiply these two numbers on top. And I don't know, I'm going to go off to the right for the moment. So how do we multiply scientific notation without just going straight for the calculator? What? Okay, so we're multiplying the 3.7 and the 4.5. And go ahead and throw that in the calculator if you want. What is 3.7 times 4.5?
16.65.
Okay. Times 10. When we do 10 to the 5th times 10 to the 9th, it's a like base, so we keep the base of 10 and add the exponents, yes? So then we have 16.65 times 10 to the 14th. Technically, that's not scientific notation because 16 is bigger than 10, but we're in the middle of a problem, so it doesn't matter right now. Denominator is still 1.8 times 10 to the 4th. Now, we multiplied on top. Now we're going to divide. Can we do the same tricks?
Yes.
Yeah.
Subtract.
16.65 and 1.8 are going to actually divide. Feel free to throw them in the calculator.
9.25.
What do I do with my powers over here?
Subtract.
Yeah, it's division, so 14 minus 4 is 10. Again, could you have gotten that by plugging all these numbers originally into the calculator, getting this answer, and then changing it to scientific notation? Yes, you can. Okay, it's not right, it's not wrong, but I'm trying to show you how to use scientific notation.
So you keep the scientific notation is just one thing. It's not separate. You want to distribute all of the numbers.
Correct. Yeah. And because now, if this was plus signs in here, then we'd talk FOIL and you're distributing. But that's because they're multiplication signs. This is just one number times another number.
Okay.
Okay? Okay. Did you write the homework down yesterday?
Yes.
I'm not even going to try and write it on my blank down there. You guys have a blank. I will write it over here off to the side. It is on page 9. It starts on page 9. How's that? 2 through 22 evens. 37 to 40 all. 43 to 45 all. And 48 to 64 evens. I throw in evens when I want you to do a section, but I don't want to assign every problem. So today is the 10th.